Welcome back, everyone. So let's do some practice problems, some practice examples in naming binary ionic compounds. Binary because there's just two types of species present, two types of elements present. Ionic because these molecules have a metal and a nonmetal. And mixed in here, actually all of the metals that are in here are metals that can form more than one charge. Because of that reason, when we name them, we're going to use the stock naming system. So you should feel comfortable being able to write formulas from names and names from formulas. So for example, when I say, what's the formula for copper 1 oxide? You should look at that and say, oh, okay, I know it is a binary ionic compound. I have a metal and a nonmetal. I know that my copper, which it has the abbreviation Cu, has a charge of +1. Oxide, oh, I know that means oxygen. Oxygen is in group 6. It has a -2 charge. So if my oxygen's a -2 and my copper's a +1, I must need 2 coppers to correctly write that balanced ionic compound. So my formula would be Cu subscript 2O. That would be copper 1 oxide. Let's go to the next one. Fe2O3, what is its name? It's binary ionic compound. I look at my metal, oh, iron, yeah, it's on that list. It forms more than one charge. Let me get my, whoops, oh, I told you the name. I was trying to get my pointer here. Let's talk about how it is iron 3 oxide. I know that I need to use the stock method for this, so I need to know what the charge is on my iron. I look at my oxygen and I remember, oh, that oxygen, it's in group 6, has a -2 charge. Multiplied by 3, that part of the molecule has a -6 charge. The positive part of the cation, the Fe2 part, that must have a +6 charge. But there's 2 of them, so the only way that my charges will neutralize equal 0 is if each iron is a +3. Hence, iron 3 oxide. You would use similar thought process to determine CuCl2. This is not going to be copper 2 chloride. And remembering that chlorine's a -1, we could say SnCl4 is tin 4 chloride. Tin 4 oxide, because remember each oxygen's a -2, and there's 2 of them, so that's a -4. So that means my tin here must be a +4. And last but not least, titanium 4 oxide. If my titanium's a +4, oxygen I know is a -2, I am going to need 2 oxygens to balance out the +4 from the titanium. So that is how to tackle binary ionic compounds, writing their chemical formulas from names and vice versa. I don't have an example slide for this, but it's even easier if you have a ionic compound that has a polyatomic. So for example, if I had NaNO3, if I was to ask you to name that molecule, you would need to recognize, oh, I've got a metal, sodium, and that the non-metal part, ooh, that's a polyatomic anion. That's a polyatomic anion. NO3, that name is nitrate from the list of polyatomics that we talked about. So ionic compounds that have polyatomics as part of their formula, you name that compound by just naming the cation and naming the anion. You don't need to muck around with the endings at all. So NaNO3 would just be sodium nitrate. So in the next video, we're going to talk about acids There will be plenty of opportunities in lecture and on the practice worksheets to test your skills and to ask questions about naming ionic compounds.